To understand the concept of functional groups, first we need to understand what an alkyl radical actually is and how it is formed. To make it clear, let's take the example of methane. If we remove one hydrogen from it, then it will be changed into an alkyl radical. So we can say that whenever we remove one hydrogen from any alkane, it will be changed into an alkyl radical. In organic chemistry, we generally refer to the alkyl radical as R, but if we place any other group in place of that removed hydrogen, it will give rise to many different kinds of organic compounds, which actually is the main reason for the formation of functional groups. A functional group is defined as the group of atoms or bonds that give specific properties to organic compounds. To understand it deeply, let's look at these two structures. The first one is called propane because it contains a single bond and belongs to the saturated class of organic compounds. But if we look at the second structure, it also has 3 carbons, but it contains a double bond, and its name will be propene. It belongs to the unsaturated class of organic compounds. As we can see, the presence of single and double bonds in both molecules has actually changed their properties entirely, although both have the same number of carbons. And this is simply what functional groups do to all compounds. They actually change the properties of organic compounds when attached to them. Now, to understand functional groups in detail, we will classify them into 3 main categories, such as functional groups containing oxygen atoms, functional groups containing nitrogen atoms, and functional groups containing halogen atoms. First, let's start with oxygen-containing functional groups. We will start with alcohol. Its general formula is ROH. As I mentioned earlier, here R will represent any alkyl radical group. The OH group is called a hydroxyl group, and if it is attached to any alkyl radical, it will be called alcohol. We can take the example of methyl alcohol, which is also called methanol. Now let's move toward the ether functional group. The general formula of ether is ROR. It means that if oxygen contains alkyl groups on both sides, it will be called ether. We can take the example of dimethyl ether to understand this functional group. But keep in mind that ethers are of 2 types, such as symmetrical and unsymmetrical ethers. If both alkyl groups attached with oxygen are the same, we will call it a symmetrical ether. And if both alkyl groups are different, they will be called unsymmetrical ethers. Now we will move towards compounds containing carbonyl carbon, such as aldehydes and ketones. First, let's have a look at the aldehydes group. Its general formula is RC double bond OH. But keep in mind, here carbonyl carbon refers to carbon that is forming a double bond with oxygen. In the case of aldehydes, it is not necessary that it must contain an alkyl group. Sometimes it may contain hydrogen on both sides of the carbonyl carbon, and such a compound is called formaldehyde. Now, if we move towards ketones, the general formula of ketones is RC double bond OR. It means that in the case of ketones, it contains an alkyl group on both sides of the carbonyl carbon. Keep in mind, both alkyl groups must be present on the sides of the carbonyl group, and if we replace any alkyl group with hydrogen, then it will actually change into an aldehyde group, and we no longer called it as ketones. So we must remember, both alkyl groups are necessary in this case. We can take the example of acetone and propanone for the ketone functional group. Now we will move towards the carboxylic group. Its general formula is RC double bond OOH. Here, we can see that the OH group is attached to the carbonyl carbon along with the alkyl group. We should never confuse alcohol with the carboxylic group. Keep in mind, in the case of alcohols, no carbonyl carbon is present, and the OH group is directly attached to the alkyl group. But in the case of the carboxylic group, carbonyl carbon is present. We can take the example of propanoic acid. In the case of the carboxylic group, hydrogen can be replaced by an alkyl group, and such carboxylic acids will be called formic acid. Now we will discuss the ester functional group. Its general formula is RC double bond O, OR. In this case, the hydrogen atom of the carboxylic group from OH is replaced by an alkyl group, and we get a new functional group called an ester. A common example of the ester group is methyl formate. Now we will move towards functional groups containing nitrogen atoms. First, we will discuss the amino group. Its general formula is RNH2. We can take the example of methylamine. But there is another functional group called the imine group, and its general formula is RNH. Keep in mind, the amino group has 2 hydrogens with nitrogen, while the imine group will have only 1 hydrogen attached to a nitrogen atom. Now we will discuss the amide group. In this case, carbonyl carbon will be present, and its general formula will be RC double bond ONH2. To understand it, we can take the example of acetamide. Moving towards the nitrile group, it contains a carbon-nitrogen triple bond, and its general formula is RCN. Sometimes it is also called a cyano group. We can take the example of methyl nitrile to understand it. Now we will move towards halogen containing functional groups. First, we will move towards alkyl halides. Their general formula is Rx. Here, X refers to halogens such as fluorine, chlorine, bromine, and iodine. We can take the example of methyl chloride to understand it. Next, we will move towards the acid halide functional group. Its general formula is RC double bond OX. We must remember that the acid halide functional group is formed by removing the OH group in the carboxylic acid group and replacing it with a halogen group. To make it clear, we can take the example of acetyl chloride. The next functional group we will discuss is thiols, or the mercapto functional group. Thiols are similar to alcohols and are obtained if we replace the OH group of alcohol with the SH group, and we will get the thiols functional group. To understand it, we can take the example of ethane thiol. Now we will discuss how we can name any functional group in a very simple and easy way. Let's start with alcohol. Keep in mind that if a compound contains an alcohol functional group, its IUPAC name will always end on OL. For example, methanol, ethanol, and propanol. Here we can see that each molecule's name ends in OL. Now, if we move towards the carboxylic acids group, the name will always end in OIC. Let's take examples of methanoic acid, propanoic acid, and butanoic acid. As we can see, in each case, the name ends in OIC. Now, if we move towards the aldehyde functional group, the name of the aldehyde group will always end in AL. We can understand this with examples like ethanal, propanal, and butanol. Here we can see that the name ends in AL. If we discuss how the name of the ketones functional group is written or ends, keep in mind that the name of ketones will always end in ONE. We can also understand this with the help of examples such as propanone, butanone, and pentanone. Here we also observe that the name ends in ONE in each case. With the help of these naming tricks, we can easily write and remember the name of any functional group. Now we will discuss how to identify functional groups in a molecular structure. You need to focus on specific patterns of atoms and bonds that define their chemical properties. Begin by examining the molecule for atoms like oxygen, nitrogen, sulfur, or halogens, as these atoms are often part of functional groups. For example, if you see an oxygen atom double bonded to a carbon atom, it forms a carbonyl group. This group can indicate different functional groups depending on what is attached to the carbonyl carbon. If it is bonded to a hydrogen atom, it is an aldehyde. If bonded to two other carbons, it is a ketone. Another common group to look for is the hydroxyl group, which characterizes alcohols. If both a hydroxyl group and a carbonyl group are attached to the same carbon, it forms a carboxylic acid. Amino groups can be identified by the presence of a nitrogen atom bonded to one or two hydrogen atoms. Thiols contain a sulfhydryl group, while ethers have an oxygen atom bonded between two carbon atoms. You can also recognize functional groups based on multiple bonds between carbon atoms. For instance, if two carbons are triple bonded, the molecule contains an alkyne functional group. A double bond between carbons indicates an alkene, while single bonds belong to alkanes. Halides can be identified by a carbon atom directly bonded to a halogen. Functional groups are specific arrangements of atoms within a molecule that define its chemical properties and reactivity. They act as the reactive sites in a molecule, determining how it participates in chemical reactions and interacts with other compounds. Functional groups provide a systematic way to classify organic compounds and predict their behavior, making them fundamental in the study of organic chemistry. For instance, the hydroxyl group imparts alcohol properties, while the carboxyl group confers acidic characteristics. Their identification and understanding are crucial for designing chemical processes, synthesizing new compounds, and advancing fields like pharmaceuticals, polymers, and materials science. I hope this video was helpful for you and you have learned something about basic concepts of functional groups. If it was helpful, kindly like, share, and subscribe the channel for more such videos. See you in the next video.